So DeepSeek just dropped Math V2 and this thing is performing at International Math Olympiad gold medal level while Tencent quietly released a 1 billion parameter OCR model that's somehow destroying vision language models 5 times its size. We're watching AI evolution happen in real time and honestly, it's getting ridiculous how fast these releases are coming. Let's start with the bigger story here. DeepSeek Math V2 appeared on Hugging Face with zero hype, no big announcement. Just quietly uploaded like it was no big deal. But here's what makes this insane. This might be one of the most impressive math reasoning models ever released publicly. The original DeepSeek 7B shocked everyone last year by matching GPT-4 and Gemini Ultra on math tasks despite being tiny. Math V2 is built on DeepSeek v3.2 and they're claiming it outperforms Gemini DeepThink, which Google specifically designed for structured reasoning. They're saying this operates at IMO medalist capability, and it's not just solving problems anymore. It's checking its own work like a professional mathematician would. Here's the key thing most people miss about AI math systems. They only care about the final answer. Did it get the problem right or wrong? But that's not how actual mathematics works. You can't just throw out a number and walk away. The process matters. The rigor, the logic. Every single step in the derivation. That's how math competitions are graded and how real proofs are judged in academic settings. DeepSeek noticed that accuracy-only systems hit a wall. They perform great on benchmarks like AMI but completely collapse when you ask for a proper rigorous proof. You can accidentally stumble into the correct final answer without understanding anything about the actual mathematics. So DeepSeek Math V2 was built around one core principle: self-verifiable reasoning. Not just answer the question, but prove it, verify it, and admit when you've made mistakes. The training structure they created is honestly brilliant. They built what they call an examiner, which is basically a dedicated proof verification model. Think of it as the grader at an Olympiad competition. It doesn't just check if the final answer is correct. It reads through the entire proof, grades every step, explains what's good, what's missing, and what's completely wrong. And it doesn't use binary grading. They use a 3-point system. 1 point for a perfect rigorous derivation, half a point for mostly correct but sloppy work, and 0 for logical errors or missing steps. The model has to write comments like an actual grader would. But then DeepSeek realized something interesting. Sometimes the teacher gets things wrong. The examiner might hallucinate an error or randomly penalize a perfectly valid proof. That happens even with large models. So they added what they call a Metaverifier or supervisor. The supervisor's job isn't to check the proof itself. It checks whether the teacher's comments actually make sense. This extra verification layer massively improves accuracy because the system isn't just trusting one model's judgment. It's getting cross-checked by another layer. Now here's where it gets really clever. The student model, which generates the actual proofs, doesn't just output its reasoning and move on. It has to grade itself immediately after generating a proof. It writes the solution, then adds a self-evaluation. And DeepSeek went for something bold here. The model gets rewarded for honesty, not just correctness. If it makes a mistake and honestly admits the flaw in its reasoning, it gets rewarded. If it tries to bluff its way through with overconfident nonsense, it gets punished. This forces the model to actually think through its proof, reflect on weak spots, and fix problems instead of hallucinating confidence. All of this builds toward their final innovation: a fully automated closed loop where the system basically evolves itself without needing armies of human mathematicians grading thousands of proofs. The student generates multiple solutions to a problem. The teacher grades all of them. They vote on the results. The hardest problems to grade or solve become new training data. The teacher improves. The student improves. The entire ecosystem levels up together. The results are absolutely insane. On the IMO proof bench, which contains brutal Olympiad proof problems, DeepSeek Math V2 hits nearly 99% on the basic benchmark. On the advanced benchmark, it's slightly below Gemini DeepThink but still at IMO gold level performance. On the 2024 Putnam test, which is notoriously difficult, it scores 118 out of 120. That's essentially a near-perfect score. You almost never see open models hit numbers like that. But the bigger takeaway isn't just wow, it solves hard problems. The real breakthrough is the framework itself. Reinforcement learning for reasoning usually relies on final answer correctness as the reward signal. This system breaks that limitation. It rewards reasoning quality, logical structure, and the ability to detect its own mistakes, which is something general language models struggle with massively. As a result, hallucinations drop dramatically. The chain of thought becomes more stable and the model becomes much more aligned with how mathematicians actually work. DeepSeek is basically proving that if we want AI to handle real mathematics, real proofs, not just multiple-choice puzzles, we need models that can verify reasoning, not just generate it. Math V2 is showing how far this approach can go. Now let's switch gears because Tencent also dropped something targeting a completely different area, and it's just as impressive. They released Hunyuan OCR, a 1 billion parameter OCR expert model, and this tiny thing is beating major multimodal giants on OCR-focused tasks. Models like Qwen VL, Gemini Pro, and even some commercial APIs. This shouldn't be possible at this size, but Tencent pushed insane amounts of engineering into this system. Hunyuan OCR is built very differently from most OCR systems. Usually you have a big pipeline with multiple steps. Detect the text, slice it out, recognize it, try to rebuild the layout, hope everything lines up. Tencent basically said, why are we still doing this, and packed everything into a single end-to-end model. You give it an image and in one forward pass, it handles text spotting, document parsing, information extraction, translation, and even visual question answering without relying on external modules. There's no chain of tools that can break. The visual encoder is really clever. It starts from a SIG-LIP foundation, but Tencent expanded it so it can take images at their original resolution and aspect ratio instead of forcing everything into square crops. That matters hugely in real-world OCR because documents come in every shape: long receipts, wide tables, multi-column pages, weird screenshots. The model breaks images into patches that match the original proportions so it doesn't lose structure. This is why it works so well on long text lines, complex layouts, and low-quality scans. After processing the image, Hunyuan OCR uses an adaptive connector module that compresses visual tokens into something shorter and more manageable, without losing important text-heavy details. This keeps the language model light and fast. The language model itself is just 500 million parameters but equipped with something they call 4D rope. Instead of treating everything like a flat sequence, it splits positional understanding across 4 dimensions. The text itself, page height, page width, and time for video frames. So it understands how things are placed on the page and how they connect spatially. That's why it can parse multi-column PDFs, follow cross-page flows, handle tables and forms, and even read moving subtitles in video frames. Training was a massive multi-stage process. Tencent fed it pure text, synthetic OCR data, multilingual samples, difficult documents, and massive long context data. They gradually increased the context window all the way to 32,000 tokens so it can handle long documents without collapsing. After supervised learning, they pushed it further using reinforcement learning with verifiable reward signals. The model only gets rewarded when outputs are perfectly aligned with ground truth structure, correct bounding boxes, accurate text, proper translations. If it outputs broken data or drifts off format, zero reward. That's why its structured outputs stay so clean. The results honestly don't make sense for a 1 billion parameter model. On Tencent's internal benchmark of 900 OCR images across 9 categories, it hits 70.92 overall, beating systems like PaddleOCR and general-purpose vision models. On OmniDoc, one of the hardest public document understanding benchmarks, it scores 94.1 with really strong performance on formulas and tables. These are performance levels you expect from models several times larger. On messy real-world documents, printed and folded under terrible lighting, it still scores over 85. On multilingual documents covering 14 languages, it hits 91% and sets state-of-the-art results. It even won first place in the ICDAR 2025 competition for document translation in the small model category. All of this from a model with only 1 billion parameters running end-to-end without extra modules. Hunyuan OCR feels like a turning point. We're seeing compact OCR specialists replace huge pipelines with single streamlined models. They're small enough for production use, handle over 100 languages, and beat much larger general-purpose vision models on tasks that actually matter in the real world. So here's the question worth thinking about. Which direction wins long-term? Highly specialized small models or giant all-in-one systems? The AI race is moving so fast that we're getting breakthroughs in completely different directions almost weekly. Drop your thoughts in the comments because this conversation matters. Make sure you're subscribed because we're tracking every major development as it happens. Thanks for watching and I'll catch you in the next one.